All right, welcome back. So, logarithms, what are those things? Well, we have a log b of x. So, this right here, this is what we call the base of the logarithm, okay? So, b is the base. And this, once again, would be the argument. Well, not once again, but this would be the argument of the logarithm in this case, which would be, if I'm not mistaken, let's go right here to the book. Yeah. So, yeah, I was mistaken, so never mind that. So we have a logarithm with base b, and the argument would be this right here. And how do they work? Well, they're actually quite simple to understand in the first place. Then they get really complicated, but that's not the point. So if we have, let's say, for example, logarithm base 10 of, let's say, 100. Okay? Basically, what it's telling me is find an exponent which we can elevate, or we can use on a base of 10 in order to achieve a value of 100. So the logarithm in base 10 of 100 would be equal to 2. Okay, I know you'll be like, what the heck is going on? Well, let's make it simpler. When we have logarithm base 10 of 100, you can just equal it to x. Okay, what you're going to do, you're going to take this 10, you're going to take this x in the exponent, right? This is what we had in the previous, when we were talking about the inverse functions. So 10 to the power of x must be equal to 100. And again, you may be wondering, but how do you get 2 from that? Well, for now, a little bit of analysis. So 10 to the power of what number is 100? Well, that's 2. So x is equal to 2. Now, a different way, a different approach could be, well, 10 to the power of x is equal to 100. We have to make the bases equal. So it would be 10 to the power of 2, right? Our bases are now equal. So x must be equal to 2. That's a different way to see logarithms. All right, so this is how they work, sort of. But before we can actually move forward, I want you guys to first practice a little bit with these types of problems. Let's see right here. All right, so example number 1. Changing from logarithmic to exponential forms. Okay, so it says right here, 2 is equal to the logarithm in base 5 of x. It says we use the fact that y is equal to log of b, to the logarithm in base b of x, means that the base to the exponent must be equal to the argument. All right? So basically we take 5, we elevate it to the power of 2, and that will be the value of x. And what's 5 to the power of 2? It's 25. So the number that must be inside here must be 25. Yes? No? Más o menos? Hope you guys understand that. For the letter b, so now we have 3 must be equal to the logarithm b of 64. So we take b, we elevate it to the other side of the equation, must be equal to 64. So b to the power of 3 must be equal to 64. Do you know any number that when elevated to the power of 3 is equal to 64? Well, it's actually 4. 4 times 4 is 16, times 4 would be 64. Okay? But we don't have to solve it yet. You just get used to the fact of how they work. All right, so I'm going to do one more example in my notebook from your work for the week as soon as I find them. Here we go. So I'm going to do 2 examples. Okay? I'm going to do problem number 1, and then I'm going to do problem number 9. Right, so your work for the, by the way, your work for the week is from 1 to 20, just the odd numbers. All right, actually, so yeah, because I'm gonna assign you the odd numbers, let's start with number 2. So number 2 is 6 is equal to logarithm base 2 of 64. So all we have to do is write this in the equivalent exponential form. We don't actually have to solve it. So 2, we elevate it to this number. Right? So it would be 2 to the power of 6 must be equal to 64. And that's it. That's all you have to do for these problems. Notice that the base, this number right here, is not ever going to be an exponent. Okay? This is your exponent right here. This is the base. And right here we have the argument. Okay? Or what we're working with in our function. And this was just logarithm. Right? So number 10, let's do number 10 instead of number 9, would be 5 to the power of 4 is equal to 625. So in these problems, it's asking us to do the opposite. Write our exponential form in the equivalent logarithmic form. And this one's a bit more tricky. But if we follow these steps, it's actually quite simple. So the base is going to be, well, the base. So this is our base, right? We have a base and an exponent. The exponent is in the other side of the equation. So we would have something like 4 is equal to the logarithm. And the base, once again, is the base of the exponent. It doesn't change. So what we're left with is the argument. 625. Sorry, my recording skills are not very good, not while I'm doing 2 things at once. All right, so 4 is equal to the logarithm base 5 of 625. And that's it. Basically, what this means is what number, when we're trying to find the logarithm, it's asking us, what number do we have to assign as an exponent in order to find or to reach 625? In this case, it would be 4. Okay, this is just to get you used to the idea of what logarithms are actually about. All right, so as always, if you have any questions, feel free to message me. And yeah, that's it. Have a nice day.